Hi everyone, David Maley here, and we're back for part 2 of this series on correlations and external data and determining relevance. So the second part is more of the proof in the pudding. So we want to go back to our executives or requesters and say, hey, this external data, in this case the violent crime against our internal data of total sales, that it has relevance or it has an effect or it doesn't. We want to be able to document that. So we're going to end up in the end with a graph like this. We're also going to end up with many more graphs and some other stuff that I'm going to show you here. So this is where we get the visuals in this video that are really cool. So we've already done some things in the previous video on correlations and various tests with that and getting p-values and the correlation figures from numerous different methods in the first video. If you haven't seen that, go back and watch that first, okay? Now, in this one, what we're going to do is we're going to plot the correlation. So let's go here. Let's open this up a little bit so you can see the code and our notes in here. So first what we're going to do is we need to have the data in a range of -1 to 1. So let's look at, remember we had data 2 and we had data 3. So data 2, we want it in the -1, 1. If it's not in that range, which it's not right now, it won't work. So what we're going to do is we're going to do this right here. So we're going to take the correlation function, COR, of data 2, which is our original data set, right? If you don't remember what it is, here it is again. Week number, date Y, total sales, transactions, units, average T, rank 1, and violent crime. The main things we're looking at right here is total sales for the week number and year and violent crime, okay? So let's go back here. So what we're going to do is we're going to take this function, we're going to pop it up into this vector called core data. So let's do this, okay? Next, so that goes up here, so that, okay. What that did was it created a matrix. Okay, so next what we're going to do is we're going to do this right here, which is CorePlot. And remember, this comes from the, right next to, I have it written down for you to see here quickly, the CorePlot package, which we have loaded up above in the previous video. Okay, so CorePlot function is run just like this. We put our data in here, which is in the matrix form right there, and then the method. Now there's 3 different methods. There's more than 3. There's many more you can use, but we're going to stick with 3 main ones that most people would use or pick from, and there's a reason for that. The first 2 are probably the ones you're going to use most often. If you want to put your circles, your colors, your observations together, your reds and your blues, the negatives and the positives, then you may want to use the third one, hclust. But first one we're going to use is circle. So let's do this one right here. And each of these has the same kind of formula. The only difference is the order that we use at the end. The method or the order is a little bit different. So let's do this. Let's do circle. Okay. So let's hit Control and Enter, and there we go. This is your typical correlation plot when people want to see one, and it shows you all of your variables, right? Your columns. Okay. And it shows, so you can sit here and look at week number and date Y. Well, they have a negative correlation. Negative correlations are right here. It tells you on the side. The red or darker red is a negative, and the darker blue is a positive. Obviously, the clear is a 0 where there is no correlation. So if I look at this one right here, units and week num, there's no correlation there. If I look at total sales and transactions right here, I have a big blue correlation. And then it depends on how dark it is as to, so like this is a big correlation, but it's not as strong as this one. Okay, and you can look at that and figure out what you want to do with this and how you do it. Now, maybe I don't want to see the colors, or I want the colors, but I also want the correlation numbers, right? So the next one is, instead of method equals circle, we use method equals number. Okay, so let's just do this and look at the difference. So instead of seeing the little circles or bubbles colored, now I actually have the colors, but I also have the numbers. So I know that this is a strong 0.74. This gives me a little bit more to go on, but it's not as visually nice as some requesters like, so that's why I'll put both of them in there, the previous one and this one, because this one I use more. It just quickly, here, somebody that's familiar with correlations can look at that and say, oh yeah, there's your correlation at 0.74, and there's your negative correlation at 0.56, okay, or 0.46. But now, what if I want to show the first one? Now remember, look at the first one. Let's go back and do it again, okay? And see how there's reds here, and there's reds up here, and there's blues over here, and they're kind of all over the place. What if I want to see it with them together. What I mean by together is the blues together and the reds together. I want it in that order. So what we would do is order by hclust. So it's this core data again, order equals hclust. So let's do that. Boom. It changes the order of it. It's the same as the circle one, but it changes the order around. So I have the blues all together and I have the reds together. Okay. Now, if that's what you want, it depends on what you're showing. Okay. Now we can also go and get more data out of this. So if I want to look at the R, the N, and the p-value. So remember we did that earlier, right? We did our core, and it showed us that we had the in the top group we had the correlations, then we had the number of observations, and then below it we had our p-values, right? So let's take a look at this. Now what we're doing is the R core function, but we're popping it into a data frame, right? So let's do that. It's not going to show me anything yet, okay? Now where we're going to use this is later on. If we wanted to, I could take this now and I could run this, right? So that just saves this. I could run this if I wanted. That's what we were talking about earlier. So I have the p-values and I have the R value, or the correlation values, and the number of observations. So if I wanted to look deeper into that, if I wanted to graph that, I could here. I'm not going to, but I'm just showing you how to do that if you wanted to. Now, next, what we have to understand is we do have 8 columns, right? So what I want to do is I want to create a new graph from the performance analytics package, which is the chart correlation. And what we're going to do is I have to use all the columns. So you see right here I have 1 through 8, 1, 2, 3, 4, 5, 6, 7, 8, like that. If I skip one, I'll be missing a column. So if I put 1 through 7, I would be missing the violent crime column, which is number 8. And I want to put them all together through this into data 4, right? And so watch what happens here. Let's do that. And what I'm going to do is I'm going to pull this in right here. Okay, and the chart correlation is going to show this on data 4, a histogram and multiple things. So watch what happens. This is again from the performance analytics package. So let's hit Control and Enter, and look at this. Now let's bring it up so we can see it a little bit better. Let's see if it works. There we go. Okay, so what this does is it gives me a breakdown of numerous things. It gives me the histograms on each of these diagonals. See this right here on the diagonals right here. So, and I can see what it is right above it: week number, date Y, total sales, which is important to me, violent crime, which is important to me, or in this case it is, and transactions and units. Now below this, what it's going to show you is a scatter plot with a fitted line. So look right here. See these are the scatter plots with fitted lines. And then above this is the correlation values and their significance in stars. So remember we were talking about the significant values were like total sales and transactions and units. Okay, and you can see everything. This agrees with everything we've been looking at. So remember I told you there's a positive correlation between total sales and violent crime. So if we look at those, see the values and the stars. Okay, so that's what we want to see here. This just further backs up what we're doing in multiple ways. So we can sit here and look at the histogram. We can look at the correlations. We can look at the significance. We can also, and it's all here in this plot. And on top of that, below, we can actually see the data in a scatter plot with a fitted line and compare them. Okay, so we have all of that. So we have another graph here. That's what this one is. That shows me that. And this is how we did it. So again, here is the code for that. Okay. Now next, what we want to do is another one. Now this is a scatter plot. So what we're doing is I'm taking data 2, right? It's our original data, and I'm putting in data 5. Let's just put it there because I don't want to mess with data 2 because I might use it again. So then what we're going to do is we're going to take data 5. And we're going to take the week num column, which is week number, right, 1 through 52 or whatever, depending on your data if you're using different data. And we're going to put it in a factor. We're going to factor that, right? So the factor function is right here. And we're going to put that back into, see this data 5, this is data 5. We're going to put it back into the week num column. So basically what we're doing is taking week num and making it into a factor, okay? So that's what we're going to do here. So let's do this. This is an easy one. All we're doing is putting it from one vector into a new one. Okay, and then what we're going to do is this one, which puts it in there as a factor. Okay, and then this scatter plot called GGScatter, okay, is from the GGpub package, which is up above. Again, we showed that in the earlier video. And so this is basically the code for that. So what this does is it creates a scatter plot based on the factored data of week number and total sales. So we're not bringing in violent crime in this one and total sales. Okay, I'm bringing in week number and total sales. I could bring in week number and violent crime. We could do that too. But what you'll see is your X needs to be a value or a column with a small amount of values. So for instance, if I used total sales for X, we'll have a bunch of numbers down below. It looks like garbage and it won't come out correctly. It'll just look like garbage. So this is more of a graph for showing, you know, against week number, against quarter, against month, something like that. Okay, you probably wouldn't want to use it as against day unless you had a smaller range. So if you had a data range of like 2 weeks, you could use day. Okay, but if you had a whole year, you'd have 365 points or 365 days down below. It'd be a complete mess. So let me show you what this does. We've already run these two, right? So we ran the previous two. Now what we're going to do is just run this GGScatter piece, right? So there we go. Now it looks like garbage down below. That's what it would look like if I used days for a full year. Okay, but we're not doing that. So let's bring this and open it way up. Okay, so let's give it a second. Bam, it pops. Now see how I have a row, each week is down below. They all fit in. And this shows me the data of total sales and how it goes over 52 weeks, ups, downs, highs, lows, all this stuff. Okay, but it doesn't show me anything else. This just shows me a scatter plot. I want to see this, but I want to see this with violent crime, total sales and violent crime together, so I can better show, you know, hey, this is what's really going on. So I brought this in, not necessarily that you would show this to your requesters, but this is to show you what a scatter plot would show based on GGScatter, but it's not going to give me everything I want. I could use this for myself and say, okay, this is how the data plays out, but let's do something more. So let's go back here, okay, and what we're going to do is we're going to use GGplot, right? So for GGplot, if you have a question of what the form is of your data, you're going to use str, okay? So in this case, you would put whatever your data is. So let's do this. And if I wanted to look at data 2, remember data 2, let's look at it. Let's make sure it's in the correct format, right? It is in a data frame. Remember, so data 3 is a matrix. So you got to make sure the one that you're using is correct. If I look at data 5, let's take a look at that. Let's see what that is. Remember, we just used that one. What is the format of that one? Data 5 is a table, is a data frame with tables. So we could use data 5 in this if we wanted to. This is going to, basically what we're doing here is we're lining up for this GGplot code down below here. And this GGplot code will only work with a data frame, not a matrix. So with that in mind, we know that data 2 so is data 5, but data 2, we know our original data is a data frame, so we're good. We bring in data 2 right here. Then we have our aesthetics. Our aesthetics are our X and our Y. We want, and this has to be the exact spelling of the column, so we have our X is total sales in this case, and our Y is violent crime. Now what we're going to add to this is we don't just want the points, which is what geom_point is going to do below here, but we also want a smooth line. So we have and make sure when you do this that these pluses are on this side, not in front of it. It won't work. So if you know GGplot, you have the pluses are on the right always. Okay. So this is the code, and we have geom_point and stat_smooth. Stat_smooth gives us a line with upper and lower bounds. So watch what happens here. Let's take this, and remember that graph I showed you at the early beginning of both these videos in this series? Well, look, here it comes, but let's open it up bigger. Let's make it bigger so it's more meaningful. There's our scatter plot. There's our total sales. But what's cool is this time it's not by week number, right? This can't be done in the GGScatter plot because these numbers are too big on the bottom, okay? But they can be done in GGplot. So this is where this is really cool to show, you know, the actual breakdown of violent crime versus total sales. And this is how it works. So as total sales, look at this line, as total sales goes up, so does violent crime. Now it's not a 1-for-1, because a 1-for-1 would go right along this angle right here. See that? That should be this angle right here. It'd be going up right like that. But see how close it is to that? So that's like a 0.75, 785, and that's what we were looking at, right? So when we look at that, this proves that here's our data, and here, as the violent crime goes up, so does the total sales. Look at that in every case. And so we can predict beyond this, you know, if we grow our business, as violent crime grows, our business is going to grow based on these numbers. Now, there's other factors and things that could be playing in here, but what this is telling you is that there's a very high probability that the violent crime has an effect, the local area violent crime has an effect on the total sales for kratom sales at this local head shop. And it thusly, because that's a large portion of their sales, that means that their sales are greatly affected by local area violent crime. So the premise here was we wanted to be able to prove beyond the shadow of a doubt that there is correlation or there isn't, that there's relevance or not with an external data column, or a column of data, or external statistics. Okay, so you could have used any. We could have brought in weather. We could have brought in population statistics. You know, people moving out of that area or something like that. We could have used anything. We could have used nonviolent crime. We could have used, you know, whatever's available to you. And you know, some things you have to pay for membership to get. There's different sites to do that. But this was based on freely available data for a store and its local area crime statistics. But this shows you how you would go through this. And now you can go back and think about, look at all the graphs we did, right? Look at the tests that we did. And in each one of these, if I open this back up, I can show you how we went and we have sections where we said, okay, here's our results, here's the graphs, and I wrote down in comments here. So you could go and actually document this now with pictures of the different graphs that we did. Remember the one we did with the histogram? And where is that? This one here. So if I went back and did this one, we could show this one, and this one shows all of the different points. The last one is obviously the most meaningful and for your requester, and the reason being it's very simple. Here's total sales, here's violent crime, and here's the line, and here's what actually occurs. That's this guy right here. So let's bring that back up. Okay, and then you bring your tests in, the Pearson and Kendall and those that we did earlier. In the previous video, you put that in, document it, and you're ready to go, and here's your proof. Okay, and then from that you can go and say, okay, well, we need to look further into this now. That's what happens a lot of times in these data science and data analytics requests. You know, if I want to do a deeper dive, I have to be able to document and prove why I want to do that and what I think would come out of that. And if I build a good use case on, or a good case on that, then they'll approve it and I can do it. If I don't do this, I just come, yeah, it's good. I looked at some graphs and it's good. And I don't give them this. They're going to be like, well, we need proof. We need, to see the numbers. We need to see the output. Now, I'm going to do another series right after this that's going to do this same data, but what we're going to do is we're going to use it with R Markdown. And R Markdown is just a really cool tool to help you with documenting stuff. So I'm going to take this and we're going to create another series that's going to help us to document and make a very professional looking document based on our findings here. So we're going to do this again, but we'll do it in R Markdown. But you now have the gist and the code here, and I've walked you through it to basically be able to do what I just did. And we just proved the relevance of this external data, violent crime, on our data set and the total sales, internal sales of this store or their kratom sales. So I hope you found this helpful. Please take a moment to like and subscribe down below so you can be notified of when the next video series, which is going to be the R Markdown stuff, comes out, because you're going to definitely want to see that, because R Markdown is awesome. And I'm going to show you some cool tricks in there that are going to make it so it's even better, because there's limitations to R Markdown and things that weren't included yet. Maybe they'll be included in a newer version, so I have to bring in some other packages, and I tweak it and we customize it and we make it really awesome. So you're definitely going to want to stay tuned and be notified of that, because that's just really, really cool. All right, thanks again for watching. Please make sure, if you haven't yet, like and subscribe down below, and have a really awesome day. Thanks.